Hello, assalamu alaikum. Hello, assalamu alaikum.
Walaikum salam.
Okay, bismillahirrahmanirrahim. Okay, we are approaching to the end of the chapter number 2. The second last topic we have convergence of the iterative method. We already finished the idea about the root of a nonlinear equation, and we discussed the approximation of the both type of the root, simple root and the multiple root. For the simple root, we used for numerical method, bisection method, fixed point method, Newton method, and the secant method. And among them, the Newton was the best one. Then we discuss the approximation of the multiple root, and for approximation of the multiple root, we use only one numerical method, which we call the modified Newton method. And I gave you the modified Newton method in two shapes, with one with the M and other without the M here. And of course, in exam, teacher will never mention you which shape of the modified formula you have to use. Is depend on the alpha. If alpha is given, then always use with the M here. And if alpha is not given, then you have to use the second modified Newton method here. Modified Newton method, best formula for the multiple root we have here now. Now we have a new topic, which I give you some idea before. I repeat again here now. We have the topic called convergence of the iterative method. Now in this topic, we will consider different type of the iterative method. They already converge. No need to check they converge, already converge. We only have to check their speed of convergence or the order of convergence. Order of convergence mean they are slow or the fast we have here. That's the things we have to discuss here. So generally in this topic, we not need f of x. We need only g of x. So we have to work on g. And the previous topic, all topic, we work on f generally. But in this topic, we are given the iterative formula, xn plus 1 equal to something, and that right-hand side of the xn plus 1 always equal to your g of x. Then you play with the gx, and then you can easily find out the order of the convergence. If we go for the definition, as I told you, this is slightly difficult to work on the definition. What we have now, we are finding the sequence approximation xn and running from 0 to infinity. So we have to use different iterative method. Generally, we do what? To find x1, x2, x3, x4, and like continue. And these approximation are converging to the alpha, the exact solution we have here now. And then I define the error in the n step. Error in n step is what? Exact minus approximation and the n step. And then we can have to define a constant beta which is not equal to 0, and r must be greater than 0. Then if this condition happen, that alpha minus xn plus 1 taxim by alpha minus xn power n, if this is equal to, of course, alpha minus exact minus approximation is error. This is error in n plus 1 step, and this is in the denominator. We have also error in the n step. And when n approach to infinity, if this quotient becomes some constant, then we call this R is the order of convergence. The order of convergence will give you the idea your method converges slow or fast here. We can have a different value of R, but generally in our topic we discuss R equal to either 1 or the 2, and because the method we discuss in up to now 5 numerical method, and all 5 numerical method are either they have linear convergence or the quadratic convergent. Maximum is that one. For example, you remember that one for simple root approximation. What we use? We use bisection method. Its order of convergence is linear. R is equal to 1. Then we discuss fixed point method for the simple root, and also its order of convergence is equal to 1, which is also the linear. Then we discuss Newton method, and Newton method, its order of convergence is the 2. Order of convergence is the 2. And we discuss secant method, and order of convergence of secant method is 1.69 or 1.7 we can call. So now you can see here, this is, we call R equal to 1, which we call simply linear. R equal to 2 we call quadratic, and R equal to 1.7 we call superlinear. Superlinear mean not linear, better than linear, but of course not better than the quadratic case. In the case of multiple root of a non-linear equation, we discuss only modify Newton method, and modify Newton method for multiple root, its order of convergence is 2, and 2 mean is a very good, is a fast convergence. But if we have a multiple root and we use simple Newton method, and I told you simple Newton method for multiple root is not a very good one. Why? Because its order of convergence is a 1. We have many methods for the non-linear case exist. They have the order of convergence is 3, 4. Of course, as the value R is more than 2, it becomes faster and faster. As you increase the value of R, the method becomes faster. But in our chapter number 2, we discuss 5 numerical methods, and generally their order of convergence is either 1 or 2. Therefore, I mentioned here now. Now, if we have R equal to 1, then we can call convergence of the sequence is the linear. Order of convergence of the method is linear. Linear means slow. And if R equal to 2, then convergence of the sequence of the method is quadratic. Quadratic means the fast we have here now. But as I told you, to use this definition is difficult, because we have to convert into this quotient form. Then we take what is the power coming in the denominator, and the power in the denominator will show you the value of R which we are interested. That is called order of convergence. And I give this example, but it is difficult to use that one here now. So you can have, this is example, leave that one here, 2 example. Let's we take the simple rule to check the order of convergence is a linear or the quadratic here. Very simple condition we have here now. You remember I give you this one before. If the value of g dash is less than 1, your method is always converge. This is a condition. If for every value of x موجود inside the interval, it belongs to the interval, if the derivative of g is in the absolute sense is less than 1, then it is 100% guarantee your method is converge. And now we go further in it to check its speed of convergence. We use this condition for the linear case. If g dash alpha not equal to 0, then for any initial approximation we choose, which is inside the interval, then your iterative method. This is not fixed point, please. This is any iterative method where g and g is different for the each problem. Then we say this method will converge only linearly to the fixed point alpha, because I told you here we are discussing not f, only g. And when we talk g, we always say the fixed point, not the root. We say the fixed point. So this is very simple. If we use this, the original definition, as I told you, you have to convert in the quotient form, and then denominator, power of the denominator will give you the value of r, which is difficult. This is very simple way to approach to r. And what is that one? It is if g dash alpha is not equal to 0, then your method converges only linearly. Linearly mean r equal to 1. So what is linear convergence mean? Linear convergence mean r equal to 1 we have here. For example, let's say we have a very simple example. He say, check this method converge linearly to the fixed point alpha equal to 2. So very simple one we have here. Now, what is your right hand side of xn plus 1? I told you always your g of x. Now, you can easily check here because 2 must be the fixed point. And you can find what does the fixed point mean? Fixed point mean is such point when we put into the function and the jawab is the same function, then we call the fixed point. So you can see easily here it is the fixed point here. Now you simply, when you have the g, only one minute job to find its derivative. And when you find the derivative, we know the derivative of g is equal to this one, because derivative of 0.40, this is 1, and derivative of x square is 2x, and 2 multiplied with 0. So we have this one. And now you check the derivative of g at given fixed point 2. So you can check here, it is not equal to 0. Then we say this scheme or this formula is converged linearly. And linearly mean r equal to 1 we have here. The same way we can go for the quadratic case, which we say r equal to 2. And what is that one here? The opposite of that one here. We say that if we have alpha is the solution of the given equation, then we can say this one. G dash alpha is equal to 0. Here, linear case, we say what? G dash alpha should not equal to 0. We say linear convergence. And here we say if the G dash alpha is equal to 0, then we can say this method converge at least quadratically. At least quadratically mean is what? At least quadratic mean minimum value of r is 2, but maybe 3, maybe 4. We have no guarantee for this case here. If you find g dash alpha is equal to 0, then it is guarantee 100% the convergence of the method is at least quadratically. Minimum is 2, maybe the more than 2, but if we need exactly r equal to 2, then I give you below the formula. First, I give this example. It's very not simple. It is a very simple example. So simple example always I say is not a very important part here from examination point of view. Let's say this iterative scheme, because as I told you in this topic, we will not considering f, we are considering only the formula, and formula mean xn plus 1 equal to something, and something always your g of x. You say this iterative formula converge to alpha equal to 1. As I told you, we will not checking is a converge or diverge. Is already we know it converge. Only we need to check speed of convergence, order of convergence. Converge is slower, the fast. Now you say this formula is converges to alpha for some value of k. Question is what? Find the value of a for which the convergence is at least quadratic. That means, what is the value of a when this method is converged at least quadratic? So what is at least quadratic condition? I give you already. At least quadratic condition mean g dash alpha is equal to 0. So it means, what is your g given? The right hand side of xn plus 1. So this is your g. So you can find, easily check here. G1 is a fixed point because when you put 1 here and you can have this job. Now you have to put this converge. Then we can check here g dash alpha. And what is g dash alpha? Is this one. G dash x is equal to this one. Derivative of g is equal to this one. Now what we use, the condition given by the teacher is the convergence is at least quadratic. Quadratic means g dash at alpha should equal to 0. So that means you have to put in this formula, in place of x, you put 1 and then put equal to 0. Why we put equal to 0? Because the condition given here, the convergence is at least quadratically. So when you find g dash here, put in place of x is equal to 1, put equal to 0, simplify, and inshallah you will get the value of a is equal to 1. This means the convergence of this formula, iterative scheme in the formula, is at least quadratic for the value of alpha equal to a equal to 1.
Doctor?
Yes.
Why it's not 1 over 3? I think
1 over?
1 over 3.
Why 1 over 3?
Because we have... Oh, no. I didn't see the minus. Okay.
It's okay, because when you open this one, it is minus 1 minus a plus 2a.
Yes.
So now you can have a minus 1 plus a equal to 0. That means a equal to 1 we have here now.
Okay.
So please remember two formula I give you. Guarantee linearly converge. That means guarantee r equal to 1. What is the condition? G dash alpha should not equal to 0. The second formula I give. G dash, it is guarantee G dash alpha is equal to 0, mean the convergence is at least quadratic. That means minimum value of R is 2. But if in exam teacher say only quadratic, then you have to go further, which I give you generalized case here. Now this is the note for the generalized case. Any order of the convergence we have here now, please. And what is this one? He say the sequence, the formula converges only quadratic. In exam, if teacher say only quadratic, mean guarantee only r equal to 2, sorry. Not minimum, only, at least, not at least. At least means g dash alpha equal to 0. But here guarantee only r equal to 2. Converges only quadratic mean g dash alpha should equal to 0, but g double dash alpha should not equal to 0. That's the condition you have to check. If teacher say at least quadratic, g dash alpha equal to 0 only, you need to check this one. But if we say only quadratic, then it means you have to check first g dash alpha equal to 0, and then you also have to check the second derivative is not equal to the 0. And the same way we can continue. The order of convergence is cubically. Cubically mean order 3. Order 3 mean r equal to 3. And what does that mean? R equal to 3 mean g dash alpha equal to 0, g double dash alpha equal to 0, and g triple dash alpha should not equal to 0. And if generalized case, if the order of convergence is r, then it's mean all the derivative of g before the r. That means g dash, g double dash, g triple dash up to gr minus dash alpha must equal to 0, but g dash, gr should not equal to 0. Then we say order of convergence is r. So you can see the student, as I told you before, a student always confused with order of convergence and order of multiplicity. An order of multiplicity, we need to find m. An order of convergence, we need to find r. Order of multiplicity mean how many times your multiple root is repeating. And order of convergence mean your method converge slow or the fast we have. Right? Any question, please, up to now?
Doctor?
Yes.
Sorry, R mean the order of convergence?
Yes.
Okay, thank you.
R is the order of convergence of the iterative method. Order of convergence or speed of convergence. Then your method speed is what? Slow or fast? If someone asks you, what is the order of convergence, order of speed of 254 a student by using car? So always very fast, huh? Always very fast. Now let's we have this question. Please, this question I can give you in the exam. This is a good example. You have to be just, he said find the value of K1 and K2 such that the iterative scheme, this is a formula, converges quadratically to r equal to 1. Quadratically mean only quadratic, r equal to 2. So you need to find out the value of K1 and K2. So how many constant we have, please, here? 2 constant, K1 and K2. So it's mean we need 2 condition. Can you give me which 2 condition you have to use here? Any student, please. Teacher give you condition that this method converge quadratically to alpha equal to 1. The fixed point is 1 here. So what you need, because when you have 2 unknown, you need 2 condition to find out the unknowns. Can you give me which condition you will use?
We should have the first derivative equal to 0,
Yes,
and the
this
second
is
one
one.
equal to 0.
What is the second?
The second derivative doesn't equal to 0.
No, but second derivative not equal to 0. So not equal to 0 is what? We don't know. Because second derivative is not equal to 0. Maybe 1, maybe 2, maybe 20, maybe 1 million.
That's right.
Yeah, this is not giving. This is okay. G dash alpha is equal to 0. But we need one more.
Maybe if x equal to 0.
F, we don't need F here. We need only G.
G alpha equal to alpha?
Yes, that's the things we need here. Because what is alpha in this topic mean? Alpha mean the fixed point. And what is fixed point mean? G of alpha must be equal to T alpha. So how many conditions you can use here for this problem to find K1 and K2? You have G1 equal to 1. And then what is the other condition you can use? G dash at 1 must be equal to the 0, because that two condition will give you the idea about K1 and K2 here. So I use here now. This is the second part. I will come on the second part here. Let's solution here. We are given the right hand side, and the right hand side is this one. Right hand side always your G of X. So this is your G given. So first condition you have to check, G1 must be equal to 1. So you put in place of X is a 1. So you have K1 plus K2 minus 5. And this is equal to what? The 1, because 1 is a fixed point. And when you simplify this one, you have the first equation is you take minus 5 on the other side, 1 already majood on the left hand side. So K1 plus K2 equal to the 6. Now you use the second condition. For that you need to first to find the derivative. What is the derivative of G is 2K1X, and we know derivative of 1 over X is always minus 1 over X square. So we have this one. Now you use the condition, this one, G dash 1 equal to 0. Then you use 1, and which is we have a 2K1 minus K2. This is equal to 0. That means you have a this. So you have a 2 equation, 2 unknown. How easily we can approach to the solution for K1 and K2. And when you do this one here, when you find K1 equal to 6 minus K2, you put here, you can have value. It's very simple to find out. And when you simplify, you have the value is K1 is 2 and K2 is 4. Now, because teachers say converge quadratically, also mean the G double dash should not be equal to 0. Then you can easily also show this one, because some student, when they did this example, they finished, they stop here. They say you ask to find out K1 and K2, this is the jawab. But you have, for this jawab, your second derivative should not be equal to 0, because quadratic condition, I mentioned you what? Quadratic condition means G double dash should not be equal to 0. So now you can find out the G double dash, and the G double dash is this one.
Doctor,
Yes.
how did you say K2 equal to 4?
K2 equal to
4.
4. What is your K2? Find from here. Second equation. What is the value of K2?
6 minus K1.
2K1, right? From this one. I'm not doing this one. What is K2? It's 2K1. Put this value of K2 in here. So what you have? K1 plus
2K1.
K2 is 2K1, right?
Yes.
This is equal to what?
6.
6. So this becomes 3K1 is equal to 6. It means K1 is equal to what?
2.
2.
Okay, then you put the 2 in the second equation.
2 is here. So
yes.
K1 is 2, means 2 multiplied by 2 is the 4 we have.
Yes, okay, clear.
Okay?
Yes.
Now, then we find the second derivative of G, which is the second derivative of this is 2K1 and this. Now you know the value of K1 and K2. When you put the value of K1 and K2 at X is equal to 1, you have the jawab 12, which is not equal to 0. That's the condition is satisfied. It means your K1 and K2 are correct value which satisfy this condition. Now go back to the second part of the question here. The second part of the question is, what is the order of convergence of this method? What is the order of convergence of this method when this method is converged to the fixed point alpha equal to the K? So how can you find the order of convergence, please? I give you the generalized formula. Order of convergence, how can you find out? You take the first derivative. If first derivative is not equal to 0, stop. And you see order of convergence is a linear. Then you go further. If k dash alpha equal to 0, then you find out the second derivative. If it is second derivative equal to 0, you find out the third derivative. You have to stop when the derivative of g is not equal to 0. And the order of the derivative g is not equal to 0. That is the value of r. So when I do this one, I need, this is the formula given. This is my gx. And I find g dash is this one. And when I find the g dash this one, and I check g dash at the alpha. What is alpha given by the teacher? Alpha given by the teacher is a square root of k. You put here and it is become 0. So it means when it is 0, it means we continue. Then we find out the second derivative. And then we check second derivative. It again becomes 0. It means we continue. When we find the third derivative, and third derivative is equal to this one, and of course k is not equal to 0, then we have no. But of course we cannot give you this problem in the exam because it will be very lengthy, because your function is a not very simple one. Your function is, your g is what? G is in the quotient form, and quotient rule you have to use 3 times. It's very difficult. So what I did last time when I gave this problem in the exam, I just make it simple. I say show that the order of convergence of this method to the fixed point alpha equal to k is at least quadratic. So at least quadratic mean what you have to show, please?
We have to show that the second derivative is 0.
At least quadratic.
Yes, the second derivative is 0.
No, at least quadratic mean g dash alpha equal to 0, please.
Yes.
Yeah, that's I mentioned here. What is at least quadratic mean? At least quadratic mean this one, g dash alpha equal to 0. It's mean for this case, you need to find only this step and you stop here. You understand me?
Yes, clear.
Yeah, that's the things you have here now. And in the exam, in place of k, I put any other number, right? So I can put it, I put k equal, I say this sequence is converged to the fixed point alpha equal to √3. So k is 3. So it means I put here what? 9 and here 3. So same thing, in place of this, I put k equal to 3. So you can do the same thing. And then you have to show this is the first derivative should not equal to 0. Stop here. No need to go for the second one and the third one. Is okay? So please, I repeat again. Your method converge linearly. It means you have to show g dash alpha should not equal to 0. Your method converge at least quadratically mean g dash alpha should equal to 0. And order of convergence is only quadratically. This means g dash alpha equal to 0, but g double dash should not equal to the 0 we have here. And if we say order 3, so if we say r equal to 3, what does this mean? G dash alpha 0, g double dash alpha 0, but g triple dash alpha should not equal to the 0 we have. As I give some example here you can do for this one. Yeah, this is the example I gave in the final exam last time here. Now, this is okay. This is a complete problem now. He says, show that the rate of convergence of the Newton method at the root alpha equal to 0, x mean alpha equal to 0 of the equation x square ex is equal to 0 is a linear. The rate of convergence for this Newton method is a linear. Can you give me, can you have the idea when he say linear, what will be the alpha? Alpha which root? When your Newton method converge linearly? Any student? Linearly means slow. When Newton method converge slow?
When it's equal to 0 gx?
No. In generalized case, you have two root, simple and multiple root. When Newton method converge slow?
When it's equal to 1?
Oh, Allah is one. Allah is one. Please, I told you, not one time, 20 times here, Newton method converge very slow when the root is multiple. And Newton method converge very fast when the root is a simple. So when I mention here, show that the rate of convergence of the Newton method is linear for this alpha, it's mean it is guaranteed this alpha is the multiple root. Then the second part I say, use the quadratic convergence method to find x2 using x0 is equal to 0.1 and compute the absolute error. This type of problem come in the exam. So Newton method is converge linear. Now he say use quadratic convergence method. What is the quadratic convergence method mean? What is a quadratic convergence method, please? How you are the student of me, Allah. You not revise your lecture, please. Quadratic convergence mean the faster method. And which faster method is for the multiple root?
Modified Newton.
Yeah, khalas, this is the things I'm asking. Wallah, you need too much, wallah. You need too much to study, wallah. This is the way I'm asking you the question. It is not good, but you are not giving me the answer here. And then you remember Tamareen marks, 10 marks. I will give you 10 marks. Then you will see how marks I will give you. Now, the first, how can you say the Newton method is converged linearly? You need the Newton formula in the form of G. So what is your F given? This is your nonlinear equation, this. You need F dash, right? And then you put in the Newton formula, and this is your Newton formula for the given equation. Now we want to show that Newton formula converge linearly. So we need what? We need G of x. And we know anything on the right hand side of xn plus 1 is gx. So this is your gx. Now you take the derivative of this. And what is the derivative of this one? The derivative of g is this one. And then you have to check the derivative of g at what? At the alpha. What is alpha given? 0. And derivative of g at alpha is not equal to 0. What does this condition mean, please? We discussed just in the start.
It's converged linearly.
Linear. It means the Newton method is converged linearly. The Newton method is converged linearly. That is the first part of the question. I repeat again, please. This is a very good example. This type of example come in the exam. He says, show that the rate of convergence of the Newton method for this equation is a linear. So Newton, of course, how can we show the convergence is linear or quadratic? We need Gx. It means first we have to find the Newton formula. And then this is the Newton formula for this problem. And of course, this is simplified. You have this one. This is your Gx. Now we take Gx, take the derivative and check derivative at 0 is not equal to 0. It means for given problem, Newton method converge linearly. Now he say, we don't want linear convergence. We want a good approximation, and good approximation for x is equal to 0 only come if your method is good one. And he say use quadratic method. And the quadratic method is for the multiple root is what? It is modify. And what is the formula of modify? This is the formula of the modify we have here now. It means what you need. You have to find m. And what is m? You find when you find the second derivative of the function, this second derivative of the function at 0 is equal to what? 2. It means m equal to the order of the derivative, which is 2. Then you can have here, this is the formula, modify formula is xn minus 2f. We know already what is f. We know f is what? This is f, this is f dash. And then you can put the value here. This is the quadratic convergent method, the best methods we have here. And now we have to use this formula to find out the second approximation. So when you use initial approximation, you can have the first approximation is this one. And then you use second time, you have this. And then he say compute the absolute error. What is absolute error? Absolute error is, now this is extra bracket here, leave that one. Absolute error is alpha minus x2. Alpha is your 0. Alpha is given the 0 and x2 you just find out the 0 minus this one, and this is the absolute error we have here now. Please, if still you not understand this one, ask me, I will repeat again. Please don't let me go further unless you understand. If you don't understand any example, please ask me. I will repeat again and again. But you must understand the idea. But if you're quiet, I cannot know that you know the things or not. What I give you today, inshallah, I will send you on your email a link. Use that link. All my recording lecture, majood on it. Please read that lecture again. Don't wait for the exam date. Start your things now. Okay? Any question you have for this example, please?
All clear, Doctor.
Is okay, good one.
Doctor,
Yes.
where can I find all these slides? I didn't get anything in the email. I can't find it in the Blackboard as well.
No, it's not. I will send you, inshallah, on your email today link. A Google Drive, my Google Drive here. I put all the lecture up to now. This is your lecture number 9. Okay?
Okay, thank you.
So all 9 lecture from start is majood there. Please read that lecture. Listen that one here and you will inshallah have no problem. Still you have in any topic problem, please give me email. I will send you also my office hour. Just make appointment with me on the office hour. I will repeat again on that one, inshallah. But this is not to sit quietly, is not the answer for that one. You have to be work hard for that one, please. Okay? Let's go further. Yeah, this is the example. Exactly the last semester in the In the final exam, I give this problem here. I say find the value of A, B, C such that this iterative scheme converge cubically to the alpha. What does cubically mean? What is
Means
cubically?
that
Huh?
the third derivative is not equal to 0.
Yes.
And before
Cubic,
it is equal to
yes, that mean the cubically mean R equal to 3, right? And what is the condition of R equal to 3? We have G of alpha equal to what?
alpha.
Alpha. G dash alpha equal to what?
0.
0. Good. G double dash alpha equal to 0, right? But G triple dash alpha not equal to
0.
not 0. Can you do how many constant we have there?
3.
3. It means we need 3 conditions, right?
Right.
Which condition you will use?
G of alpha.
G of alpha equal to alpha, G dash
And
alpha
the
equal
first
to
derivative
0,
and the
and
second
G double dash alpha
equal to
is
0.
equal to 0. And of course, this is in the end, we will check here. And then I say, this is your Gx, and I find Gx is equal to this one and check G at alpha. Alpha is your what? Root of 3, right? Is this one. G dash, I find this one, and I check here. So how many equation we have here now? 3 equation. 1 equal to A plus B plus C, 0 equal to A minus 2B minus 5C, 0 equal to 3B minus C. You can simplify that one, and inshallah you will get the value of A, B, and C, this one. So what is your formula become in place of, this is a formula given, unknown. Now you know the value of A, B, and C. This is the things we have here now. Then what is the second part? He say use this scheme to find the second approximation of 27 1 by 3. What is your n?
27.
27. X naught is given this one. So you use X naught and 27 in this formula. Inshallah, you will get your X1 is this, and your X2 is either this one. Can you give me what is your X 27 power 1 by 3 equal to what?
Can you repeat again, Doctor?
27 power 1 by 3 equal to what?
3.
3. And you have exactly jawab 3. And just in 2 iteration. Why? Why we have such good approximation? Just only in the second approximation.
Because we use the modified, maybe?
No,
No.
we don't have a modify here, please.
Yes, it's different.
Here we
Because
say
because R is 3. So it's very fast.
because R equal to 3, because I told you, as you take the value of R more, your method become faster and faster. You understand my point, please? Why this one? We have a very good absolute error just on the second iteration, because the method over this method is converge cubically. Cubically mean R equal to 3. And I told you, Newton method for simple root is R equal to 2. And we say converge very fast. Modify Newton method for multiple root is R equal to 2. Converge very fast. So if we take R equal to 3, your method will become faster, more faster here. So as you can increase the value of R and the method become faster and faster. Got my point, please?
Yes, clear.
Please, I request you, I will send you to my link, Google Drive link, and please check all 9 lectures is majood there. So just read that one. So when you again read and listen, then inshallah, I hope you will not have any problem. Okay, any question now, please? Is okay? Or say yes,
Yes.
okay or not.